Hey guys, Mr. McKinney here, just going through the second part of our Unit 7 review videos. So we're picking up on what we covered on the third day, which was differential equations and slope fields. A differential equation is basically just an equation that has a derivative in it. You'll usually see it written as dy dx equals blah, 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 or 5 dy dx plus 7 equals 3. So you'll have either a dy dx or a y prime or a y double prime or a second derivative of y with respect to x. You would have something like this in your equation. So a differential equation just means that that equation has a derivative in it. If I want to find functions that satisfy a differential equation, I need to get dy on one side and x on the other side. So you do what's called separation of variables. And that means you make sure that everything that has to do with y is on one side and everything that has to do with x is on the other side. If you do not do this step on the AP exam, you lose like all of the points on this type of problem. So it's really important that the first thing you do is separate the variables. On this one, the only thing you have to do to separate the variables is multiply the dx over. So dy equals 10x to the 9th plus 4x to the 5th minus 2x times dx. So to find the functions that satisfy this, it wants to know what y is, not what dy is. And so once we have y on one side and x on the other side, we can integrate. So the integral of dy, the integral of 1 dy is y, or y plus c. But I only need to put one c in, so I'm going to wait until I finish the other side. So this would become 10x to the 10th over 10 plus 4x to the 6th over 6 minus 2x squared over 2 plus c. Now, like I said, you could put plus c1 on this side and plus c2 on this side, but since we don't know what the c is anyway, you only need one of them at this point. So these are all the functions that satisfy this. This is a general solution. A lot of times on the AP exam, they will ask for a general solution, and then they'll ask for a particular solution that goes through some value. So they would say like y equals 7 when x equals 0, or f of 2 equals 5. So they'll give you a point on the original equation, and you can work backwards to find the c value and then plug that c value in to get your particular solution. So for example, I want to know the functions that go through this point, so I'm going to be finding particular solutions here. So let's separate the variables first. I want to get y on the left side and x on the right side. So dy, to get the y squared over, I would divide both sides by y squared. So dy over y squared. To get the dx over, I'm going to multiply both sides by dx. So dy over y squared equals x cubed dx. Now I need to integrate, but I need to make sure it matches one of my formulas. If it was dy over just y, it would be fine, and I could do ln absolute value of y. Since it's y squared, though, I need to rewrite this one as y to the negative 2 dy equals x cubed dx. And then now I can integrate it. This will become y to the negative 1 over negative 1, x to the 4th over 4 plus c. At this point, I need to plug in my x and y and figure out what c is. So 1 to the negative 1 divided by negative 1 equals 0 to the 4th over 4 plus c. That's all 0. 1 to the anything is 1. You can move it down there if you want. 1 divided by negative 1 is negative 1. So c would be negative 1. So plug that back in here. Y to the power of negative 1 over negative 1 equals x to the 4th over 4 minus 1. Technically, this is correct. A lot of times on the AP exam, it'll say find the particular solution, y equals f of x, that satisfies this point or whatever. So a lot of times you're going to need to solve for y. So this is really, I can multiply both sides by negative 1 to get rid of that. So y to the negative 1 power equals negative x to the 4th over 4 plus 1. This is really like 1 over y. I can make this one fraction, so negative x to the fourth plus 4 over 4. And if you just have one fraction on each side, you can just flip both sides. So y would be 4 over negative x to the fourth plus 4. There's other ways to solve for y. This is just one of them. All right. The other topic that goes along with differential equations is slope fields. A slope field is basically a visual representation of a differential equation. So a slope field will show you the value of the slope at any given point of the original equation, essentially. A lot of times on the AP exam, you're only going to be worried about integer coordinates, so you're not going to have to draw the slope marks at infinitely many points because you would never finish. So many times it'll be the integer coordinates, and they'll specify pretty clearly which ones they want. So for example, dy dx equals x divided by y. So at every point, I'm going to take x and y and plug them in here, and then figure out whether I should have positive slope or negative slope or zero slope or undefined slope, and then graph it accordingly. So for example, I know that when x equals 0, like 0 divided by anything is going to be 0. So all of these points are going to be 0, which means the slope is 0, which would be a horizontal line. The exception to that is 0, 0. 0 divided by 0 is undefined, so you won't have anything here. On the AP exam, they wouldn't even have that dot, because they wouldn't ask you to draw one that you can't draw. Okay, let's look at when y is 0. So anything divided by 0 is going to give you undefined slope. So negative 2, 0, negative 1, 0, 1, 0, 2, 0. If I plug those into this equation, I would get an undefined value. The next thing I would look for is where am I going to get a slope of 1? So when x and y are the same thing, I would get a slope of 1. So 1, 1, 2, 2, negative 1, negative 1, negative 2, negative 2. If they're the same number but opposite signs, my slope's going to be negative 1, and then so on. You're just going to plug in each point one at a time. I'll do one more point. So this point is the point 3, sorry. This is the point 1, 3. So 1 divided by 3 would have a slope of 1/3. On the AP exam, they're going to be primarily looking at your slopes that are 0, your slopes that are undefined, and then they're going to compare like a slope of 1/3 and a slope of 1. 1/3 should be less steep than 1. They're not going to get super duper nitpicky and say, hey, this isn't really a slope of 1, that looks like a slope of 1.5. They're just going to be looking to make sure you have positives or negatives, and that if it's supposed to be steeper, you draw it steeper. So don't get too caught up about drawing them perfectly. Okay, the other concept is once you have the slope field drawn, you can sketch the particular solution. So in this case, it would look something like that, or potentially like that, or probably both of those. This wouldn't be a function, so depending on how they ask the question, you might only need the top half or the bottom half. The last day in this unit was basically looking at AP type questions having to do with definite integrals. And there's a video series that I recorded on this, so if I go too fast right now, just go back and watch those. The main thing to keep in mind when you're dealing with definite integrals on the AP exam is that if you start with an equation, and you take the derivative, and you take the derivative again, there's a relationship between these. And when you go down levels, you're taking the derivative, and when you go up levels, you're taking the integral. Now, f prime, and f double prime is just one example. You can do this with anything. And so at the top level, you would have an amount, and then you would have a rate of change. And then if you take the derivative again, you have a rate of change. So if I start with a rate and I want to know an amount, I need to take the integral to move up a level. If I start with a rate and I want to know how that rate is changing, or how the rate, then I would look at the rate of change. So then I would be taking the derivative. The most common example that you see has to do with position, velocity, and acceleration. So position is an amount of distance. Velocity is a rate of change of distance. And acceleration is a rate of change of a rate of change of distance. So if I want to go from velocity to position or distance, I take the integral. If I want to go from acceleration to velocity, I take the integral. If I want to go from position to velocity, I take the derivative. So position, velocity, and acceleration is the most common example, and I can almost guarantee it will pop up on the AP exam. But it doesn't have to be limited to just position, velocity, and acceleration. It can be any rate of change with an amount. So you could have like the number of butterflies, and then the rate of change of the number of butterflies, and then the rate of change of the rate of change of the number of butterflies. So use derivatives to go down levels, use integrals to go up levels. All right, so if g is defined as the integral of f, then FTC says that g prime, if I do the derivative of the integral, it's just going to be f, and if I do g double prime, it would be f prime. Since I have a graph of f, an integral of f is talking about an area on the graph. G prime is just f. So if I'm trying to find g prime, I'm just looking at the values of f, which is just going to be a point on this graph. And if I'm asked about g double prime, I'm looking at f prime, which is basically the slope of f, or the slope of this graph. So to answer different questions, if I wanted to know when g is increasing, any function is increasing when the derivative is positive, or in this case, when f is positive, which is when the graph is positive. So up here. If I wanted to know when g is concave up or down, then I'd be looking at the second derivative, which is the same as the first derivative of f. So I'd be looking at the slope of this graph and looking at whether the slope was positive or negative. All right. The next type of problem is a very common one on the AP exams, and it has to do with accumulating rates. So in this problem, we are given two different rates, and we are asked how many people, so an amount or a number of people, is going to be the integral of a rate. So when you're answering these types of questions, make sure you pay attention to what they give you. Even though capital E we don't think of as being a derivative, this equation, since it's a rate, it's the derivative of some amount equation that we don't know. So pay attention to what they give you in the problem. If they give you a rate, you're already at the middle level here. So if you want to go to an amount, you would take an integral. If you want to know how the rate is changing, then you would take the derivative. And then the last example is basically having to do with Riemann sums. The most likely way that you would see a Riemann sum on the AP example is with a table of values. And it would tell you to do some sort of Riemann sum. So for example, you could say use a right rectangular approximation method with, let's see, 1, 2, 3, 4, 5, 6 intervals as specified. So this interval has a width of 1, this one has a width of 2, 1, 3, 1, and 1. So make sure you pay attention to the width of the interval, because a lot of times on the AP exam, they will not be equal intervals. They will be unequal. You could also do any, like you don't necessarily have to use all the data depending on what they ask you to do. So pay close attention to the way the question asks it. But Riemann sums are another way to take a definite integral. They're another way to approximate the area underneath a curve. Or a lot of times on the AP exam, instead of being people here, this would be something like velocity, and it'll ask the distance that's traveled, or to approximate the distance that's traveled using a trapezoidal sum or a midpoint sum, and then you'll create a Riemann sum based off of the table. And again, there's videos that go over this. All right, hope that was helpful. Remember that the Unit 7 exam this year covers the Unit 6 material and the Unit 7 material. Basically everything that we've learned about integrals so far this year. Good luck.